6.6 question number 6. Slight variation as a question which you had done before. In this we have to prove that if it is a parallelogram, the sum of squares of the diagonal is sum of squares of the four sides. Now if it was a rhombus, it would have been very easy, and we have done that type of questions in the previous exercise. Now here it is not given it's a rhombus. Here it is given that it's a parallelogram. So only the opposite sides are equal. So what we need to prove is that the sum of squares of the diagonals, that is AC square plus BD square, is sum of squares of the four sides, AB square, BC square, CD square and DA square. So since it is squares, I am using Pythagoras, so I have to construct this. I am drawing DM perpendicular to AB and CN perpendicular to AB produced, right? So perpendiculars are necessary to get the right angle. So first I am going to find out the value of AC square. So you are taking this triangle ACN, and what is AC square here? AC square will be AN square plus NC square. Okay, that's my first equation. In the second, we have to find BD square. So how will I find BD? I'm going to take this triangle BDM. In triangle BDM, BD square will be BM square plus MD square. So we've got the second equation. Both these are by Pythagoras theorem. So equation 1 by Pythagoras theorem, equation 2 by the same reason by Pythagoras theorem. Now we are going to add the two equations. Now when you add the two equations, we'll get AC square plus BD square equal to AN square plus CN square plus BM square plus DM square. We are simply adding the two equations. Now we don't require this, we require the side. So what we are going to do is do some replacements. So instead of AN, we can write AB plus BN. Look at the figure. AN can be written as AB plus BN. So I am replacing AN with AB plus BN. CN square, now if you look at this triangle, this is a right angle triangle. So CN square can be replaced with BC square minus BN square. So what we are trying to do is get it in terms of the sides. So we are replacing CN with the side of BC. So CN square can be written as BC square minus BN square plus BM. Now BM can be replaced with AB minus AM. BM can be replaced with AB minus AM. So here we've got BM as AB minus AM whole square plus DM square. DM square we are writing as AD square minus AM square by Pythagoras. DM square replaced with AD square minus AM square. So each of these terms have been replaced with sides of the parallelogram. Now here we are going to apply the A plus B whole square formula. So we get A square plus B square plus 2AB. And here we are going to use the A minus B whole square identity. We get A square plus B square minus 2AB. Now positive bn square and negative bn square cancels. Positive am square and negative am square cancels. And 2ab bn and 2ab bn and 2ab am, this should ab am will get cancelled because ab is as it is equal, and bn and am can be proved equal because these two triangles are congruent. How are they congruent? AD and BC are opposite sides of a parallelogram, so they are equal. Angle M and N are 90 already given, and DM and CN are equal because the distance between parallel lines is always a constant. So these two triangles can be proved congruent by RHS. Okay, so AD equal to BC, condition 1, M and N 90, condition 2, and DM is equal to CN. Distance between two parallel lines is a constant, so triangles are congruent by RHS. So if the triangles are congruent, AM and BN are equal, so we can cancel off positive 2AB BN and negative 2AB AM because 2AB is as it is common and BN and AM are equal. So what are we left with? We are left with AB square plus BD square is AB square plus AB square, that is 2AB square plus BC square plus AD square. Now let this remain as it is because these are already sides of the parallelogram. AB square, there are two, so one AB square we let it remain as it is. The other AB square can be replaced with CD square because AB and CD are equal, right? Opposite sides of a parallelogram are equal, so AB and CD are equal. So one of the AB square we can replace with CD square, and therefore we can conclude that sum of squares of the diagonals of a parallelogram is the same as sum of squares of the sides of the parallelogram.